Hi, today we're going to be looking at lesson 18 and we're going to be exploring fractions as division. So when you look at a fraction problem or you see a fraction, you see a bar and then above it you see a number, which is the numerator, and the bottom, which is your denominator. Okay, I want you to see the relationship between that and a division sign. Do you see how they both have a fraction bar? Okay, and then instead of a number on the top and the bottom, they have those dots, and that's showing that it is division. So that is just another way to write a division problem is through a fraction. So I'm going to show that one more time, maybe making it a little bit neater this time. Okay, so if I write a division sign, imagine replacing a dot with a number, and then replacing the bottom, the numerator, with a number. Now it's 3 divided by 10, which is the same as 3/10. So if I have 3 pieces of pie and I divide it among 10 of my friends, they will get 3/10. So it's kind of a cool little way of noticing that this bar really means divide. So if you have 3/10 of something, you have 3 wholes that have been divided into 10 parts. So you have 3/10 of it. And we'll see with some drawings and some division on why that works and get a little bit of clearer view of some real life situations of that. Okay, so up the top it says you know that division is used for equal sharing and that fractions represent a number of equal parts of a whole. In this lesson, you will learn how division and fractions are related. Use what you know to try to solve the problem below. So as always, when you see a problem like this and you're given a lot of space, typically in class, if we had normal class, you would have some time to kind of explore it a little bit and then maybe talk with other people, share some strategies. So if you want to pause the video and try to solve this yourself your own way, you're very welcome to do that. I think that's actually a great strategy. But if you're like, you know what, I'm not really sure, that's okay at this point just to kind of watch the video and follow my steps. But I think if you want to challenge yourself, go for it. Mrs. Tatum needs to share 4 fluid ounces of red paint equally among 5 art students. How many ounces of red paint will each student get? So with these kinds of questions, you have to really be careful on what is your numerator or what is the number being divided and into how many parts. So just be really careful and think about, is it 4 divided by 5 or 5 divided by 4? Because they are very different things, unlike multiplication where it doesn't really matter. So if I look at this question, I can see that there's 4 fluid ounces of paint, and the paint is what's being divided among 5. So the 4 is being divided into 5 parts. Okay, and that looks a little strange because we have a dividend here of 4, which is smaller than your divisor of 5. So if I were to write that as a division problem, it would look like this. My 4 is being divided into 5 parts, which does look a little bit different than what we've done previously with division. Usually you see this dividend as being the bigger number. So here they're going to end up with less than a whole. So I like to really write that down. So the 4 is my 4 ounces. Really write down what I'm doing. And I'm dividing it into 5 people. Okay. So if I were to draw a picture, I think squares and rectangles are just easier to work with than circles for me. So I know I have 4 ounces of paint, and I could do a number line, and I would normally erase this and make it a little bit more equal, but let's imagine all of my squares there are equal. And I have to divide those 4 equal parts among 5 students. Well, I can't give them each one. That doesn't work. So what I'm going to do is I'm going to go ahead and divide each one into 5 parts. And now I can see that I have 20 pieces there. I have 5 pieces or parts of all of my 4 wholes. So I can write, and this is going to be difficult for me to do, but I could write like an A for the first person. It's kind of hard to write. Oh, really small in here. B, C, D, and E. Okay. And I think that's a good strategy to think about your people as A, B, C, D, or E. Or if you wanted to use colored pencils, that would be great too, to show all the A's are one color, all the B's are one color, all the C's, all the D's, and the E's. So either labeling it with letters or even numbers, 1, 2, 3, 4, 5, or with some colors, just to really visualize the pieces that they're getting. So they went ahead and said, you know what? We're each going to get part of each of these wholes. And we're not going to get a whole at the end. We're going to get parts of 4 of the wholes. So I can see here that the A person, each person is getting 1/5, and they're getting 4 of them. So they're going to end up with 4/5 of an ounce. So they have 1/5 here, each person. They get 1/5 of each of the wholes, which is going to give them 4/5 of an ounce. So there's another way to see that 4 divided by 5 is the same as 4 divided by 5, the fraction. So they get 4/5 of an ounce. Now, if I were to try to divide it, I could. What I'd want to do, though, is I'd want to add a decimal zero. Oops, that looks really messy. Let me try that again. I would need to add a decimal 00, kind of thinking of it like money. And then I would be able to divide that out. And if I did, I would get 0.80 or 0.8. So that's 80 hundredths or 8 tenths, which is equivalent to 4/5. So here I have a visual, a picture that works. You can see that 4 divided by 5 is the same as 4/5. And the division, if I were to find the decimal, I have an equivalent decimal. So hopefully if you did, pause the video and then take a look at your work. You might have done it very differently, but just realize that you should have got the same answer, whether that's 4/5, 8 tenths, or 80 hundredths. All of those would work. Okay, looking at number 2 on the next page, this is just giving you a suppose or changing the question a little bit. And it says, suppose Mrs. Tatum wants to share 8 fluid ounces of paint equally among the 5 students. You can think about this quotient in 2 ways. You can think about each student getting 1/5 of each ounce. So if you shade 1/5 of each hole in the model below to show the student share. So here, if they were to do that, this time we have 8 fluid ounces. So we have double the amount of ounces. They're going to get double the amount at the end. I hope you shade a little bit better than me. I'm shading with the pen though. So here they're going around. They're going to go ahead and get 1/5 out of each of one of those holes. And if you can see then, she ends up with 8 groups of 1/5, which is the same as 8/5. Usually we don't write 8/5 just because that's an improper fraction, but that's the same as 1 whole and 3/5. If you look down here, what they did is they went ahead and made the whole that we just talked about, that 8/5 really is the same as 1 and 3/5. These 5 right here, they put that together to say that's the same as a whole. And then I had 3 of these holes left that had 1/5 in each one of them. So those 5/5 up here just showed it as 1 whole. And then these 3 1/5 are still right here. So that's just showing that that's another kind of way to think about it and kind of group that up. I see my whole and I have 3 more fifths. Okay, down at the bottom it says write the quotient 8 divided by 5 as a fraction and a mixed number, and which we did right up there. So 8 divided by 5 is the same as 8/5 or 1 whole and 3/5. Okay, the reflect there at the bottom says, how would you write the fraction 2/5 as a division expression? Write a word problem that can be represented by your expression and the fraction 2/5. So if we're writing 2/5 as a division problem, remember division looks like this, right? It's 2 divided by 5. Okay, so if I replaced it 2 divided by 5, right? There's my division. And then your word problem, I want you to think about something that you can have 2 of, and they're dividing it equally among 5 people or 5 days. So it can be as simple as there's 2 candy bars. I divided that equally among my family of 5. Or I had 2 miles to run and I gave myself 5 stopping breaks. What is the length of each of my running times before I stopped? Or I have $2 and I want to divide that among 5 people. Something like that. We're going to go ahead and kind of move past this next page and then just jump to the number 2 on the bottom of it where it says write the fraction 3/4 as a division expression. So 3/4, I want you to think about as a division problem. 3/4, here's the division sign, as 3 divided by 4 equals 3 divided by 4. Okay, it says how could you use multiplication to check your answer? So you could use that inverse operation. That 3 divided by 4 is 3/4. So if I look at it as multiplication, what I would have to do is I would look at it. Let me start that over. I'm going to write it up here so it's not so big. If I say that 3 divided by 4 equals 3/4, then if I change that to multiplication, just like I've done before, these numbers, my divisor and my quotient, if I multiply them, 4 groups of 3/4 would equal 3. So I can say if I have 3 pies, I divided that among 4 people, they each get 3/4. Or I can say 4 groups of 3/4 would equal 3 pies. Okay, number 3 on the next page, we have our grams of glitter. Okay, and it says Mrs. Tatum needs to share 3 grams of glitter equally among 8 art students. How many grams of glitter will each student get? Again, with this, you really want to think about what's being divided up. In this case, it's the 3 grams of glitter is being divided among 8 students. So we have 3 grams. That's what's being divided up. And it's being divided among 8 students. Do you think to yourself, if I'm dividing that up among 8 students, would they each get 1? Well, no, because there's only 3 there. So there's no way they're going to get a whole. So it's going to be a part of a whole. And if you keep in mind that 3/8, 3 divided by 8 is the same as 3/8. We can show that even with a picture. So if I did a picture here, if I have just those 3, which you have the pictures up there, you can even use those. Okay, and I divide that into 8 parts, each one into 8 parts. And I think about each person getting 1 part. So I could do different colors for each person. I could do the A, B, C, D, E, or I can say each person is getting an 1/8 of that. So each person is getting an 1/8 of each of the wholes, which is 3/8. So again, I could have put that A, B, C, D, E, F, G, A, B, C, D, E, F, G, H on each one of them so you can see, or you can see that each person's getting an 8 that way too. Okay, I could do division too if I wanted to. I could say the 3 is being divided among 8 people. and I'd have to put a decimal 00 here, and I would just divide as I normally would. I'm going to kind of see a visual of that. Just as I normally would, I just want to remember that there's a decimal there. So if I divide it as I normally would, 8 doesn't fit into 3. 8 fits into 30. Am I drawing a blank here? 3 times. There we go, which is 24. I subtract and I have 6 left, and I bring up the 6. And then 8 fits into 60 7 times, which doesn't fit in perfectly, which is 56. And I have 4 left. I could keep going, and that would give me a 5 here. If I went and added an extra little 0 here and kept going, then I would bring my 4 up. 8 fits into 45 times. Okay, and it's kind of a weird looking decimal, but 375 thousandths is the same thing as 3/8. They mean the same thing. It's just not a super friendly decimal. Okay, and then that is the end of what we're going to go over today. So hopefully that makes sense to you, that you're seeing that fraction can be written as a division problem. And when you see problems like that, you're able to kind of break it down and really think about what's your dividend and what's your divisor.